4.3 is really, I put it with 4.5 and 4.6 kind of. And honestly, the very first thing that's listed here in 4.4 with our like side angle, all the different congruence things. So we're going to do that on Monday. On Tuesday, we're going to do 4.7, if I'm remembering my numbers correctly, 4.7. And today we're going to do 4.4. But 4.4 is truly just, I'm going to talk through some of these theorems, point out some things from pictures, and then I'm going to do, there's no example problems of solving in the examples. So I'm going to use the homework section to do a few examples, and then I have a sheet of practice for y'all that goes with it. Tomorrow we have our quiz on 4.1, 4.2, and 4.4. Ultimately, I feel like what we're doing today here is still just practicing all of that, besides not making those statements of, okay, tell me angle N is congruent to angle whatever in the pictures, right? Like, that's not in this specifically, but the rest of it pretty much is. So, with this here in 4.4, I'm really going to look at just a couple of things here. So, in this picture, I want to point out that you could be given this little picture, and over there to the side, I'm just going to zoom in and write it on here so I don't have to keep moving it. It says that OM is a perpendicular bisector of LN. Okay? What does that tell us?
The midpoint.
Okay, so what two sections are made equal?
LM and MN.
All right, so LM and MN. So what I'm trying to point out here is when you're given that little piece of information, write it on the picture of what that tells you. Okay, that told me about the bisector. What else can I label on this picture? That doesn't tell me the triangles are equal.
Could you do M as the midpoint?
So I did, and I showed that those two sections were equal, right? Like that's what, when you just told me that LM was equal to MN. But what does this piece tell me?
Oh, opposite reciprocal.
Okay, yes, but not complementary. What does perpendicular make? Perpendicular lines make what? A 90-degree angle. So it tells me that I have a 90-degree here, which of course means I have a 90-degree there, right? Yeah. And we have to remember that this picture, I know it looks like they were 90, right? Like we all would say, well, before you drew those little squares on there, you would say it looked like they were 90 degrees. But you cannot assume they are 90 unless it tells you they are perpendicular or tells you that they are 90 or tells you that they're right angles. Like, you can't assume it, okay? So, do not draw those in unless you are told something like this here with it being perpendicular. Well, the bisector doesn't make it 90 degrees. The bisector made it equal in two sections, right? The perpendicular piece created those 90-degree angles, okay? So that's one thing to keep in mind. Then we have this here. So this theorem, I've already talked about it. And the other two theorems are the same way. I've truly already talked about it. I'm trying to just like stress it in a picture form now. If two sides of a triangle are congruent, the angles opposite those sides, the base angles, are also congruent. So if I give you a picture like this here, and that's all I do is put those two tick marks, then you have to say, well, that tells me this is equal to this. Angle Y is equal to angle Z. Not, well, Miss Bash, you didn't tell me that. No, it's understood. And the flip side of that over, and I think it's like this picture over here, I don't truly have to start by labeling anything. I can give you a statement, and then we can answer a bunch of questions based on that statement. Okay? Might be on this side. Yeah, over here, the converse of that is that if I gave you this, you said, oh, I know I need to now put tick marks here, that those two sides are equal. So whether you're told that the two base angles are equal, and you say, oh, that tells me the sides are equal, and it's isosceles, or vice versa. You're told the two sides are equal, and it's isosceles, therefore you know that the angles are equal. It doesn't matter, but that's something that we have to keep in mind, is that I don't have to label them both on a picture. I only have to label one. And then the other thing here, I use this word, equiangular. It wasn't technically in 4.1, I don't think, But I used it when we were talking about equilateral. Equilateral meant that all the sides were equal. Equiangular means all the angles are equal. And if it's equilateral, it has to be equiangular or vice versa there. What did we say every angle would have to be on an equilateral? And what exactly are they on an equilateral triangle? 60. Yep, 60. So we know that they have to be 60 degrees. So, like I said, I'm going to go through a few of these examples here, and then I'm going to give y'all some to work on. So in this picture up here, I love this TV. Okay. In this picture here, remember that all of these do not build on each other. They're all separate pieces. So looking at that picture, we're going to talk through some of these, and you tell me if one of you shouts out the answer and you say, I have no clue how they just said that, stop me, okay? Do not, keep moving forward. Because I don't want it to be that I give you this sheet and you're like, I don't have a clue how to do this. But I promise there's a picture identical to this with these same questions on it, okay? So, the first one. Measure of angle BDA. This is what we're trying to find here. If we know that BDC is 90.
90.
It has to be 90. Why?
Yeah.
Why does it have to be 90?
The tick marks. But also, oh wait.
Well, but this is the one
And
it told me
says
was
it equals
90.
90 degrees, so it has
And it's
to
a
be equal
perpendicular.
90 degrees because it's perpendicular.
Okay, so yes. Or we can say those two angles together add to give us 180. So
Yeah.
if one's 90, the other one has to be 90. So both of those would work. That shows us that it's perpendicular, which in turn makes the other one 90. All right, let me erase that. All right, the next one says that, if I could see it, we want to find AB if we know BC is 10.
Ken,
My brother's here to pick me up, and he doesn't know what door to go to. So
Okay, where's he at right now?
I know that he just said he's in a parking lot.
Okay.
He said what?
All right, so then I read that one. I don't know if you said it. For number 2, if BC is 10, what does AB have to be? 10. For number 3, if A is 50, so if A is 50, what is BCD? 50. All right, number 4, if BCE, so this out here is 132, then how are we going to find A?
well, I know they have to.
What is it?
It is 48
Okay, why?
because I subtracted.
Okay, because 180 minus 132 gives you 48. And that's this one technically, but those two are equivalent.
Yeah.
Yep. All right, so that one's 48. I should be writing these down, I feel like. All right, and then number 5. All right, on number 5. Number five. Okay, this one tells us it's perpendicular, right? So that's important. Tells us we have a perpendicular piece there, so we know that this here is happening. BCE is 125, and it says to find ABD. So it says, oh, not all of that. ABD, this one. So what would we do? Walk me through it.
So I'd do 180 minus 125.
Okay, and we're at what?
That would be 55.
55.
So that would be the angle inside. And since we already know that's 90, so I had 55 to 90.
Okay.
It gives me 145.
Okay.
And then I subtract 145 from 180.
Uh-huh.
That gives me 35.
35. Yep. So, very good. All right, so we get 35 for this one. And then the last one says, what does it say? The last one says BD bisects AC. So we know we've got sections that are equal, right? AC is 24. What is DC?
12.
12. Because all we have to do is cut it in half. Okay? All right, when we're given something like this on number 7, how would we figure that out?
180 minus 20.
Okay, then what?
That's 160. And since they got the tick mark, so both equal, so I do 160
Okay.
divided by 2.
Exactly. Divided by 2. So we get 80 degrees for both of those. Okay. What about number 8?
Because they're all equal.
Exactly. They're all equal. They have to all be 60. What about number 9? And I can't remember. What did this say? It said define the measure of each angle. So It's our goal to find the measure of each angle. How am I going to do that on this one?
Okay, let's see.
So often on this one that students want to say, I just need to do something with the x and the x minus 15, and that's it.
No.
No. If we know that this is x,
Yeah.
what's this?
That's also x.
Okay.
So
What do we know about a triangle?
they all add to equal 180. So
Okay.
it would be 3x minus 15 equals 180.
Mm-hmm.
And then when so you add 15.
Yep.
That's 95.
Yep. 15. 3x equals 195.
Alright,
What is that? Divide by 3.
I think so.
3 goes into that 6 times 65,
Yeah, 65.
right? Okay, so that means we know that this one's 65,
65.
65, 65, and then
That's 130. And then, yeah,
what?
190. 65 plus 65 is 130.
130, yeah.
And then plus 65 is 195.
What are you talking about?
What? 65 plus 65 is 130 plus another 65 is 195.
Okay, why are you telling me that?
I was just making sure.
Oh, okay.
I was thinking out
I'm
loud.
so
making
confused.
Sure that's right.
I got you. Okay, I'm just very confused because I was like, well, that's not the angle we're trying to find here.
Yeah.
65 minus 15, we could just say
I was
this one
just
here.
making sure x was 65.
I gotcha. But yeah, so that situation, we remember, and the biggest thing that is always forgotten here, I feel like, is this extra x. 9 times out of 10, if a student misses this one, it's because they said 2x minus 15 equals 180, and they forgot that third x. So, good job. Don't forget that x. I think that's all that I wanted to look at here, but on this page, let's look at this guy. Okay, take a minute to look at it, take in what you're seeing, and tell me how you would approach starting this one. Take in what you see, and then I'm going to say how I would approach it if it's differently. I see 2 isosceles triangles for one, right? I see 2 isosceles triangles, but I see 1, 2, 3, goodness, 4, 5, 6 triangles altogether probably.
Yeah, 6.
Yeah. Okay. So what do you think? When you see this, what's a first thought that you have on how to go about it?
X.
Okay.
So to find x equal 3x plus 30.
Okay, so you're saying this here is a straight line.
Mm-hmm.
So those two added together should equal 180 degrees.
Yeah.
So you said 3x, just combining like terms.
Yeah.
3x plus 30 equals 180. Subtract 30. 3x equals 150.
So x equals 30.
Right, so, wait, x equals what?
No, 50.
X equals 50, okay?
Right, I got it.
Okay, so we found x.
Backwards.
Now what?
So, now I'm going to plug it in.
Okay.
So, since I got x,
Uh-huh.
so I plug into 15. Yeah, x plus 15. So
Uh-huh.
50 plus 15. That would be 65.
Okay.
And since they got check marks and they're both equal,
Right.
that would also make the other one 65.
Okay, so number 4 has to be 65, so we found one of
So
them.
that would be 130, then I subtract 130 from 180. That
Okay.
gives me 50, and that gives me the top angle.
You're talking about for angle 1?
Yeah.
Okay, because you said 65 and 65 is 130.
Mm-hmm.
180 minus 130,
Equals 50.
50. So this up here has to be 50. Okay, I'm good with that.
And then...
Now what?
Now for the third time... yeah, I'm going to go ahead and do the third triangle. But I don't think it really matters, so I'm just going to do the third one.
Okay.
So that
Do you mean like the one on the left?
Yeah.
Yeah, okay, I like that.
So I would, since that's a straight line too, so I'm trying to find the missing angle for it.
You're talking about right here?
Yeah.
Okay.
So I do 180 minus 65. That gives me 115.
Okay, so this here's 115.
Yeah.
Okay, now also, could I have also plugged it into this one?
Yeah, but
And shouldn't that also give me 115?
yeah. Yeah, that should be 115 too.
Okay.
And then,
And then now what?
so then, so, I'm thinking. So,
Okay, one thing that you haven't, just trying to give you a hint here, one thing that you haven't touched is that 100 degrees up there at the top.
yeah.
Could you use that somehow to help? Because right now you're kind of feeling like, well, what else can I do
So yeah,
with this information?
So all three of them triangles add up to get the outline angle of 80 degrees.
Exactly. All of these together make 80.
So I could take maybe out 50.
Okay, if we take out 50, 80 minus 50.
That's 30.
30.
And then I'll put 30, cut it and divide it by 2.
Exactly, divide it by 2, because these two have to be equal, right? Because ultimately, we've got all these isosceles triangles. That's creating equality here and here. Therefore, it's also creating it up here. Because remember, we looked at that thing that said on the first day, if 2 angles in one triangle are congruent to 2 angles in another, then that means the third angle also has to be congruent, right?
Yeah.
So, like, we know those have to be equal. Even though it's not because it's isosceles or any of that, we know they have to be equal. So, you're right. This here is 15, and this one's 15. Okay? So, now we're just left with angle 3, right? You found 1 was 50.
Yeah.
You found 2 was 15. Yep. And then you found 4 was 65. So we're just left with angle 3. So how are you going to find angle 3?
So, I'm going to do, I do 115 plus 15. 80.
Okay.
Will that give me angle 3?
Yeah, and so what would that be?
Or 180 minus 150.
Yep, 180 minus 130, and it gives you 50.
Net.
So angle 3 has to be 50 degrees.
Yeah.
Okay, and then
And that's
like
the same thing for the other one.
exactly, this is also 50. And what I was going to say was here, say to yourself, well, does that work? This here, 50 plus 80 better be 180 degrees, because remember how I said there were 6 triangles here?
Yeah, but
that's one of
that's a
them.
whole different-
So truly, you could check, and I'm not going to. We could check every single one of them if we wanted to, right? And we could determine, are they congruent? You know, another thing though, this just dawned on me, and I didn't think of it earlier. This 100 here is an exterior angle, and the interior angles have to add to give you the exterior. And those two are equal because they're isosceles, so we could have determined that it was 50 from the start with that 100. But I just now thought of it. Like, those are things that, you know, we can all, because for me, I started this problem with the 80 up there at the top, where you started with adding the 2 at the bottom and setting it equal to 180. So our thought process here, what I told them earlier, is notice that we didn't find angle 1 first. Like, that's not the first thing that we found. We found angle 4. But so many people, and myself included, when you see you need to find angle 1, 2, 3, and 4, you're fixed on, I need to find angle 1 first. But there's nothing that says we have to find angle 1 first. So I like how you went straight to, I know that equation is x plus 15 plus 2x plus 15 equals 180. And you started by solving for x and not focused on 1, 2, 3, or 4. And I want you to always like keep that mindset, because that will help you out tremendously on not being fixed on I have to find a certain thing first. But we also are all going to potentially approach it differently, but still get to those same answers. Okay? So, very good. Now, from here, I'm going to give you your sheet, and I need to point out a couple of things. So, we've got plenty of time. But I want to point out a few things before I just let you go on it. Up here with number 1 on A and B, I have asked you to like just state what additional information do you know based on what I have drawn in the picture. So I'm wanting you to tell me, is it an acute isosceles triangle? Is it a scalene triangle? Is it equilateral? Like those kinds of things. If there's angles that you could say, state those angles. Just try and think of all the things that you know based on that picture. In this section on 2 and 3, you're using that same picture to answer number 2 and 3, but number 2 starts with giving you angle 3, and then you find the rest of them, whereas question 3 starts with giving you angle 7, and you find the rest of them. Okay? So you're building from that first angle of 35, and you're finding 1 through 8 after that. And same thing for question 3. You're starting with that 120 on angle 7, and then you're building from there. Remembering isosceles triangles, adding to give you 180 when it's a straight line. A whole triangle is 180, those sorts of things. Down here, this is just like that problem that I did in the book a minute ago, number 1 out of the homework problems in the book. I just changed up the numbers on it. And on the back, same thing. This is just like that last problem we did, but I changed the numbers on it as well. Okay? So, it's practice straight from what we just looked at to be able to do these. Okay? You got it? I know you do. Okay? So, this here is like your homework tonight is to study for your quiz and to finish this if you don't finish it. I think you will get finished in class. But this is practicing for that quiz anyways. So, it's a perfect way to practice for it. Okay?